Motion is the act or process of moving or changing position in space. It involves the displacement of an object or a change in its location relative to a reference point or frame of reference. Distance refers to the total path length covered by an object during its motion. It is a scalar quantity, meaning it only has magnitude and no direction. Distance is always positive or zero and is measured in units such as meters, kilometers, or miles. Displacement refers to the change in position of an object. It is a vector quantity, meaning it has both magnitude and direction. Displacement is measured in the same units as distance but also includes the direction. Displacement is often represented by the symbol delta x or d. Mathematically, displacement is equals to final position xf minus initial position xi. Depending on the direction of motion relative to the reference point, displacement can be positive, 0, and negative. Distance versus displacement. Definition: the total path length covered by an object. The change in position of an object in a specific direction. Scalar or vector. Scalar quantity, magnitude only. Vector quantity, magnitude and direction. Path considers the entire path traveled, regardless of direction. Considers only the change in position from the starting point to the end point. Significance provides information about the total amount of ground covered. Provides information about the change in position and direction. Magnitude. Distance is always positive or zero. Displacement can be positive, negative, or zero, depending on the direction of motion. Example: if you travel 5 km north and then 3 km south, the distance covered is 5 km plus 3 km equals 8 km. If you travel 5 km north and then 3 km south, the displacement is 5 km to 3 km equals 2 km north. Speed refers to the rate at which an object covers distance. It is a scalar quantity, which means it only has magnitude and no specific direction. The formula for calculating speed is speed equals distance divided by time. Speed is typically measured in units such as meters per second, kilometers per hour or miles per hour. Velocity is a vector quantity that describes both the speed and direction of an object's motion. It takes into account the displacement of an object over a specific time interval. The formula for calculating velocity is velocity equals displacement divided by time. Here, displacement refers to the change in position of the object. Velocity is measured in units such as meters per second, kilometers per hour, or miles per hour, just like speed. Velocity is represented by an arrow, where the length of the arrow represents the speed, and the direction of the arrow indicates the object's motion. Speed versus velocity. Definition: speed is the magnitude of the rate of change of position of an object with respect to time. Velocity is the rate of change of position of an object with respect to time, including both its magnitude and direction. Scalar or vector. Speed is a scalar quantity since it only represents magnitude. Velocity is a vector quantity as it includes both magnitude and direction. Direction. Speed does not consider direction, it only indicates how fast an object is moving. Velocity considers both speed and direction, indicating the object's speed and the direction it is moving in. Measurement. Speed is measured in units like meters per second, miles per hour or kilometers per hour. Velocity is also measured in units like meters per second, miles per hour, or kilometers per hour. However, it is often specified with a direction. Example: 20 meters per second north. Calculation. Speed can be calculated by dividing the distance traveled by the time taken. Velocity can be calculated by dividing the displacement, change in position, by the time taken. Example: if a car is moving at a constant speed of 60 miles per hour, we only know the magnitude of its motion. If a car is moving at a constant velocity of 60 miles per hour north, we know both the magnitude, 60 miles per hour, and the direction, north, of its motion. Instantaneous velocity. This refers to the velocity of an object at a specific instant in time. It is calculated as the derivative of the object's displacement with respect to time. Average velocity. This represents the average rate at which an object changes its position over a specific time interval. It is calculated by dividing the total displacement of the object by the time taken. Velocity can be positive, 0 or negative, while speed always positive or 0, which you can also include in previous speed versus velocity table. Acceleration is defined as the rate of change of velocity of an object with respect to the time. In simpler terms, it measures how quickly an object's speed or direction of motion changes. Mathematically, acceleration a equals change in velocity delta v, change in time delta t. The SI unit for acceleration is meters per second squared. This means that acceleration is expressed in terms of meters per second, indicating how many meters per second an object's velocity changes over each second of time. Acceleration as a vector quantity means it has both magnitude and direction. Here, change in velocity of a car in each second are given. Therefore, change in velocity in each second is equals to 1 meter per second, and total change in 4 seconds is equals to 4 meters per second. Therefore, acceleration is equals to 1 by 1 or 4 by 4, which is equal to 1 meter per second square. When an object undergoes acceleration, it is either speeding up or slowing down, or changing its direction of motion. Position time graph represents the position of an object with respect to time. The slope of the graph gives the object's instantaneous velocity. Flat portions represent the object at rest, zero velocity. Positive slope indicates the object is moving in the positive direction. Negative slope indicates the object is moving in the negative direction. Zero slope indicates the object is at a turning point, momentary rest. The position time graph intersects the time axis when the object is at rest. The derivative of the position time graph gives the velocity time graph. Straight line indicates constant velocity while curve indicates acceleration. Velocity time graph represents the velocity of an object with respect to time. The slope of the graph gives the object's acceleration. Flat portions represent constant velocity, zero acceleration. Positive slope indicates the object is speeding up, accelerating, in the positive direction. Negative slope indicates the object is speeding up, accelerating, in the negative direction. Zero slope indicates the object is moving at a constant velocity. The area between the graph and the time axis represents change in displacement, change in position. The velocity time graph intersects the time axis when the object's velocity is zero. The derivative of the velocity time graph gives the acceleration time graph. Kinematic equations. Kinematic equations are a set of equations used to describe the motion of objects. Final velocity is a function of initial velocity, acceleration, and time. v equals v0 plus at. V is the final velocity of the object at time t. v0 is the initial velocity of the object at time t equals 0. A is the constant acceleration of the object. T is the time elapsed. Displacement is a function of initial velocity, final velocity, and time. Delta x equals half of v0 plus v times t, where delta x is the displacement of the object during the time interval. v0 is the initial velocity of the object at time t equals 0. V is the final velocity of the object at time t. T is the time elapsed. Position as a function of time. X equals x0 plus v0 t plus half at squared, where x is the position of the object at time t. x0 is the initial position of the object at time t equals 0. v0 is the initial velocity of the object at time t equals 0. A is the constant acceleration of the object. Final velocity is a function of initial velocity, acceleration, and displacement. V squared equals v0 squared plus 2a delta x, where v is the final velocity of the object at time t. v0 is the initial velocity of the object at time t equals 0. A is the constant acceleration of the object. Delta x is the displacement of the object during the time interval. These equations are valid under the assumption of constant acceleration. If the acceleration is not constant, more complex equations and calculus may be required to describe the motion accurately. Remember that these equations are for one-dimensional motion. For two- or three-dimensional motion, similar equations can be derived for each dimension independently.